So really quickly, I really wanted to talk, because we had ended the period with Travis saying something really important about this. And Travis, what I think you said was that it doesn't work to just check numbers, because you could check number after number after number, and those might work, but then there might be some other number that doesn't work. You can't check all the numbers. So what do you do? And so there were several people in this class that didn't just check numbers. They tried to show how you would show it would work for any number, no matter what. So let's just take about, say, maybe 10 minutes to see. And I'd like you to actually, before we even start about this, I want you to put all your pencils down. Can you see this, by the way? There's a glare in this room. So can you see the problem? So if you there's a lot of people that didn't do this extra credit. There's a lot of people that used one number as an example to check. There are several other people who used 2 or 3 numbers. Now I'd like you to think, if you were going to try to prove to someone that this always would work, how would you do it? So I'd like you to look at the board and think about it for maybe like 1 or 2 minutes silently, without talking to anybody. And then we'll see if there's any ways that we could convince somebody that would always work. We were doing before, where one person talks and everyone listens and everyone gets a chance to talk, and if you don't have an idea, you can pass. So starting with the person, like in Kimberly's position at the table. So that would be Kimberly, Charmaine, David, Pam, David. What you'll do is go in a clockwise direction, and if you have an idea, tell your group. And people that are listening, I'd like to make sure you respond. I noticed from watching videotapes that sometimes somebody will say something in the group and no one will say anything. And it's sort of like being completely ignored. So when someone comments or when you make a statement or someone makes a statement to you, there should be some kind of response, like or I don't understand what you mean, or something to acknowledge. So let's talk about that I'll see how long that takes. Taking turns again, starting with the people sitting in Kimberly's position. Okay, go ahead.
For the first, it's like, since you're doing n-1, you're just going to double that. Okay, it's just like you're doing those two, you're doing n-1 twice, and you're adding it together. Mm-hmm. Then it's the same thing as doing 2 times n-2. It's because you're still going to subtract 2 for the first one.
Yeah. Gee, that kind of makes sense.
Yeah, it's just confusing.
I know, it is confusing. So wait, you take the number and then you subtract by 1 and then you multiply it.
By 2.
But in the first one, you multiply the number, so that would equal, that number times, it would equal double that number. In the other one, it would equal double that number minus 1. And since you're subtracting by 1 and multiplying by 2, you would need to subtract by 2 to get. Okay, I get it now. Alright then.
Okay,
you guys are like barely talking.
You have an idea? Huh? You have an idea?
I just said it.
Which is the same as mine, right?
Yeah.
Okay, you can tell that.
Basically, yeah.
I can't explain it.
Alright, yes.
You can explain it.
As long as we understand.
Yeah.
Yeah, that's nice.
You can explain it to me.
I have to go to the dentist today.
I don't.
You don't.
Great, looks like you're done. All right, I will comment another time on how your discussions, how far you've gotten in your discussion about who is talking, which is what's kind of nice for me. All right, anybody think they can make a convincing argument? Like, prove these are equal for any number, no matter what number they are? Colin, you want to try?
Should I go to the board?
I think so, yeah, because it helps people not, what I'm finding is for some people, if you just listen, it's hard, but if you listen and watch, it helps. Your brain gets 2 inputs instead of 1.
Okay, so it's like this. So I found out that because it's 2n like that, this part, this is like a multiplication, so it'd be 2n, and that's just like 2n, which is right there. And then this minus 2 thing, it's like this minus 1, but because it's minus 1, and there's the multiplication by 2, it'd be 1 times 2, and that's minus 2. That's why it's 2n minus 2.
That's what I was saying.
You can all go, oh, I get it later.
No, stay there. Now, remember, convince a friend, convince yourself, convince a friend, convince a skeptic. Any skeptics?
Oh.
We got lots of people coming.
Okay, okay.
I think it works because when the n minus 1 is in the parentheses, that means you're multiplying n minus 1 by 2. And that's the same way of saying, I think n times 2 and then 1 times 2 and then you subtract that.
Exactly.
Where does the
yeah,
negative 1 come from?
The minus 1?
Yeah.
It's in
Oh, minus
the
1. I
problem.
thought it was negative 1. But anyways,
Yeah,
go
well,
ahead.
negative 1, yeah, I just call it minus 1.
How can it work if, like, you're subtracting different numbers?
Well, because
Stephanie, what's the question again? This
Well,
is called,
I'm just confused by the whole thing. Like, I don't see how it could work.
can you frame a question that we can all think about? What's your question about what?
Okay, so what he's doing is he's multiplying 2 times n and then subtracting 1 instead of doing n minus 1 and then multiplying that by 2. And so then if he's going to do it that way, then how does it work if he subtracts 2 from one like equation and then 1 from the other one?
Well, I kind of have another way of explaining it because, say for instance, n was like 5 or something. In here it'd be 4. This would be 4, so it would be 2 times 4, and it'd be just like 2 times n is 5 minus 2 would be 8 because it's multiplying the entire thing.
Thank you. Melissa, I'm going to pick on you. Because on your test you did something that nobody else had done, which is you drew pictures. Could you go up and show your picture way of doing it? So yeah, go over there. That's a good place. And do you have the fat chalk?
No fat chalk.
Because the fat chalk is a lot easier to see.
Okay, just say that n is 4. So if you have two times n minus 1, so you have to take this off, and it's not there anymore, and you multiply it by 2, it's like that, so you have that much, and that's the same as, that's like, also right there, it's still minus 1. I don't know. And if you
It's hard to draw on the board.
have 2 times n and you subtract 2, it's like the same thing.
Oh, okay. Geez.
Now that is a particular example, but the idea of the particularness helps you see why it would work for any general case. All right, raise your hand if you think you understand now why 2 times the quantity n minus 1 equals 2n minus 2. Who's still not quite sure? Raise your hand. I really want to hear from the people that are like still, like anybody kind of like this still? Okay, Leo, be a skeptic.
No.
Could you be a skeptic for any question for any? So, the way you read this, just for your information, is you say 2 times the quantity, n minus 1, is equal to 2n minus 2. So in your own words, explain why that's true. Yes? Right now, don't worry about that. Just get a new page, because I want to get you writing and get you on to your homework for tonight. Whoa.
I've had
So,
enough homework.
yes, so write, please. And pretend like you're trying to convince a skeptic. Why is 2 times the quantity n minus 1 equal to